Hey Ramblers, this video is going to cover the types of segments that we find in a triangle. We're going to cover three different types of segments in this video. The first is medians, the second is altitudes, and the third will be perpendicular bisectors. There's also some other vocabulary that we'll cover in this video. We'll learn the terms bisect and centroid, which will also come up in some of our discussions throughout the year. All right, so let's take the first look at medians. So when we think of medians, we think of the middle, like the median in a road or a highway. So the median is a segment which is drawn from the vertex of a triangle to the midpoint of the opposite side. Let's take a look what that looks like. So given triangle ABC, and if we were to draw a median, it comes from the vertex, so it would start at A, and it would be drawn to the midpoint of the opposite side. Okay? It doesn't have to meet at right angles. All a median does is it meets at the midpoint. Every triangle has three medians because every triangle has three sides. So BR would also be a median. And the last median will be drawn from C to the midpoint of AB, and we'll call that CT. All of the medians meet at a point called the centroid. So that's one of our vocabulary words, the centroid. And all medians bisect the sides to which they are drawn. So bisect means to divide into two equal parts. Now, sometimes segments will bisect another segment. Sometimes rays can bisect an angle. So bisectors are in different contexts, but that's what it always means, to break into two equal parts. Okay, the next type of line or segment in a triangle is called an altitude. So just as with medians, there are three altitudes in every triangle, but the important thing is that altitudes meet the opposite side at right angles. They don't necessarily bisect it. So is MB congruent to MC? We don't know. So we can't be sure that it's like a median. Sometimes it looks like it is, but we don't know. But every triangle has three altitudes, and unlike medians, they may not all meet at a point in the middle. Okay, let's take a look at one other kind of a triangle, because if the triangle is obtuse, the altitude may not meet or may not be inside the triangle. So for instance, if I draw the altitude from Y and have to make it perpendicular to the opposite side, I'm going to have to be outside of the triangle, and I'm going to have to extend XZ in order to draw the altitude. So not all altitudes are inside the triangle. And that's going to be a very important fact that will come up later in the year. We'll run into that a lot as we're talking about area. All right, let's go on to the last type of segment in a triangle that we're going to discuss, and that's perpendicular bisector. Okay, perpendicular bisectors are segments or lines that meet the side of a triangle at right angles, and they bisect the side. So let's be careful with that, because it's very important to recognize that the perpendicular bisector does not necessarily come from a vertex. It just meets the opposite side in the middle, and it meets it perpendicularly. So for instance, in triangle ABC, it's possible that DE does not come from the vertex A. All we know is that DE is perpendicular to BC and that BE is congruent to EC. But what we don't know is that it comes from a vertex. Perpendicular bisectors can come from a vertex in special triangles, but they don't necessarily do that. Okay, before we wrap up, let's look at a couple of problems and see how this might get applied. Some of these things might get applied. All right, so suppose we're told that RA is a median. The question is MT also a median? So let's look at the diagram. RA is our median here, and we know that MA is 3x plus 10, and AZ is 4x plus 6. So the question is MT also a median? All right, well, to do that, we're going to need to set up an equation. And since we know that RA is a median, these two segments, 3x plus 10 and 4x plus 6, must be equal because we know that a median divides a segment into two congruent parts. So let's solve for x, and when we do that, we get x equals 4. Now, in order to determine whether MT is also a median, we need to see is 2x minus 1 equal to 3x plus 5. Let's put a question mark over that equal sign, and we'll plug in. So 2 times 4 minus 1, does that equal 3 times 4 plus 5? Well, clearly on the left we get 7, and on the right we're going to get 17. So those are not equal. So since they're not equal, MT is not a median. All right, let's take another look at how altitudes can get applied in a problem. We're given some additional information that angle JPQ is equal to 8x plus 10. Now, since we know that this is an altitude, we know that that's going to be a right angle, and let's draw in that it's equal to 8x plus 10. All right, so what we want to do is answer the question how about this? Find MQ. So in order to do that, we need to set up an equation. We don't know that JP is a median, so we can't assume that these two parts, MP and PQ, are congruent. Since we know it's an altitude, we know that 8x plus 10 is a right angle, and so therefore it's equal to 90. Solving for x, we see that x equals 10, and we can substitute x into 4x minus 2, and we see that that's 38. And when we substitute in here, we see that this is 21. And so in order to find MQ, that's going to equal 38 plus 21, which is 59. Okay, Ramblers, that's how we apply these things in problems. You learned 3 different types of segments today. You learned medians, altitudes, and perpendicular bisectors. We also picked up 2 other terms, centroid and bisect. So make sure you're comfortable with all those, and that will help you do the homework. Okay, thanks for watching, and I hope this helped.